Hello friends, welcome back to my maths channel Learn Easy Maths. Today I am once again before you with some new topic, with some new discussion and also with some new interactions. Today's our topic of discussion is Pythagoras theorem. Pythagoras theorem. When we just hear the name of Pythagoras, suddenly, knowing unknowingly, we get the concept and idea of mathematics in our mind. Whether we completely understand the concept or don't. But we get something picture of mathematics. Usually, Pythagoras theorem is very popular in all the aspects and all shades of our life. Today I am here to just discuss some of the geometrical arithmetic interpretation of Pythagoras. Today I am not discussing with you how to prove that one. Today I am not discussing with you this is the result of our proof. And also I have no intention to just extract the result from this figure. The main intention of mine is just to see what is the interpretation. Usually Pythagoras theorem is based on right angle triangle. Remember this. What is a right angle triangle? A triangle is one angle is exactly 90 degree. Yes? Then we say it is a right angle triangle. The total sum of interior angles of a triangle is 180. If one angle is 90, the sum of other two angles is equal to 90 degree. Now, this right angle triangle has an unique characteristic, has an unique nature in it. What is that unique? That today is our discussion. This is a right angle triangle. Can you see this figure? ABC is a right angle triangle. Okay. Angle B is 90 and the side opposite to the 90 degree, when you just release an arrow where it hit the side, that side is called hypotenuse. Hypotenuse. The other sides are interchangeable. Interchangeable, I mean to say that when you say this is a base, this will be opposite. When you take the inverse of this, then this will become opposite and this will be base. That's going to be very important characteristic role in our trigonometric section. Let's today, this is my figure. Base is BC, opposite side is AB and the hypotenuse is AC. What the Pythagoras says, let me tell you about who was Pythagoras. Pythagoras was a Greek philosopher, was a Greek thinker, and in addition to above all, he was a great mathematician. It is believed that 520 BC to 490 BC he was lived in Greek and visited many places, among them Babylonian, the Egypt, everywhere. And he was much influenced by another great mathematician of the olden time, ancient time, by name Thales, which we study the Thales theorem in our 10th standard. Some says that even he was the student of Thales. That we don't have that historical proof. This much we can say that yes, he was much influenced by another great mathematician by name Thales. Now, what the Pythagoras says that you take any right angle triangle and you go on their three sides. Each side you need to develop a equilateral, equiangular polygon. What is that equiangular and equilateral polygon? Here, first polygon, in this one, see that what the statement say in a right angle triangle. Okay, the square on the hypotenuse, Square on the hypotenuse means what? Hypotenuse should contain or should have a square on it. It's a hint. Nowhere in the mathematical text, nowhere in the textbook, nowhere in the curriculum text we find that square on the hypotenuse means we do not have a figure of square. Square means geometrical figure whose all angles are right angle and all sides are equal. That's why I said that it is an equiangular and equilateral. The square on the hypotenuse, when you just develop a square on the hypotenuse, its area is equal to the sum of the squares on the other two sides. The square on the hypotenuse, that is AC square, AC into AC, is equal to sum of the squares. The another side is AB and another side is BC. Its square sum is always equal to the hypotenuse square. That's why square on the hypotenuse is equal to sum of the other two squares on the sides of a triangle. Now for that interpretation, I would like to draw your attention here. If the students are watching, students, please take a note and try to draw this figure and try to make this figure in your notebook. And my dear teachers, my colleagues and my viewers, you also just make an attempt for this one. What that? I have drawn here a right angle triangle. Can you see this one? Yes. AC is an hypotenuse, BC is a base, AB is an opposite side. I have given a measure or some term for each one. The length of the AC is A, the length of BC is B, and the length of AB is C. This is A, this is B and C. What is a square? All sides are equal. So you construct a square on the hypotenuse whose side is equal to A. And another side BC is a base. You construct another square whose measure is B. And on AB you construct another square whose measure is C. See that the right angle triangle, square on the hypotenuse, square on the other two sides. Okay. This is the square on the hypotenuse. And what is its area? A into A, which is equal to A square. What is its area? B into B, which is equal to B square. And what is its area? Which is C into C, equal to C square. What the Pythagoras says that the square on the hypotenuse is equal to sum of the squares of the other two sides, isn't it? So see that one. What is AC? It is a square, and area of the square is side into side, A square. Yes or no? The square on the hypotenuse is equal to what is AB? The AB. This what is AB? AB is another opposite side of a right angle triangle which has a development of the square that it is. Sorry, I made just little invert here. See that you make it. This is a AB and this is correct. B into B and this is C into C, which is equal to C square, which is equal to B square. Now, what is AB? AB is C square. What is BC? BC is what? It is a B square. The square on the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, AC square is equal to BC square plus AB square. You can just write like this also. Here, AC square is equal to BC square plus AC square. What is the area of the BC square? It is equal to B square. What is the area of the AC square? It is equal to C square. This is the geometrical interpretation. This is the geometrical interpretation of a Pythagoras theorem. Did you understand? Okay, I talked to you about the square first. A square is a equiangular and equilateral. Similarly, what are the other polygons which are equiangular and equilateral? The first primary polygon is our equilateral triangle. Can you see that one? This is equilateral triangle. Equilateral triangle. The same way, I have taken the right angle triangle and I make the statement that the area of equilateral triangle on the hypotenuse is equal to the sum of the areas of the other two sides of the equilateral triangle. This area of equilateral triangle is equal to sum of the areas of the other two sides of the equilateral triangle. That is same way A square is equal to B square plus C square. You know that what is the area of an equilateral triangle? We write it as root 3 by 4 into A square is same as root 3 by 4 B square plus root 3 by 4 c square. This is the geometrical interpretation. I hope you are following it. Not only square on the hypotenuse, you can imagine and you can just give a statement square on the hypotenuse, equilateral triangle on the hypotenuse, and a regular pentagon on the hypotenuse, a regular hexagon on the hypotenuse, regular octagon on the hypotenuse. Octagon is not a regular polygon, that's why we will not consider here regular nonagon, decagon and everything. Then the area on the hypotenuse of the polygon is equal to the sum of the areas of the same polygons of the other two sides, isn't it? If the area on the area of the polygon on the hypotenuse is equal to the sum of the areas of the other two sides of the polygon, stand on it. I hope you follow my point. This is the most important mathematical interpretation which we need to impart, which we need to inculcate our students. Actually, this kind of interpretation hardly you are able to see in any of the textbook. As for many textbook, I glanced it, I referred it, I explored it, but I do not get. It's my sincere request to almost all my mathematics teachers and my mathematics colleagues, please, you can just give this kind of assignment to your students. They will find very much interest in doing so. Here, I can take your attention to this. Here I have drawn square on the hypotenuse. Here I have drawn equilateral triangle on the hypotenuse. Here I have drawn the pentagon on the hypotenuse. Then again same, it is the right angle triangle. A, B, C is the right angle triangle. I have constructed a pentagon on the hypotenuse and also the other pentagons on this base and opposite side. This is equal to the area of this pentagon on the hypotenuse is equal to the area of the pentagons on the sum of the areas of the pentagons on the other two sides of the triangle. This is the wonderful way that we can just give an idea and concept to our students. With this, I hope today you enjoyed this interpretation, hoping with this that you will subscribe my channel. You will subscribe my channel and you will just share it and you will explore it and you just make me a very, very great achiever in making you to inculcate my knowledge. With this one, I am going to take a goodbye from you with this hope that take care of you and students give more importance for the studies. If you keep on learning and studying at this stage and at this time, by the time you reach near over the examination, you will not have any kind of stress and strain. So be happy and take care. With this, I am going to take a leave from you. Bye bye. Good night.